Hi, welcome to this lesson on Probability Counting Principles Part 1. Let's have a look at the fundamental counting principle. So in the area of probability, we are often concerned with finding the number of outcomes of some event, let's say A, that belongs to some sample or universal space S. So the fundamental counting principle tells us exactly how to count the number of objects from multiple events at once. So that's the true power of the fundamental counting principle. Whereas in previous probability problems, generally we have one space, universal space S, and usually we pick events one at a time and look at the number of objects in that event. But what if we wanted to look at multiple events at once and count all the objects in the various events and all the possible combinations that can happen? So I'm going to start off with defining what we call the Cartesian product. So let's say we have the event A in a sample space S with n1 elements. So there's 1, 2, 3, 4, up to n1. So in other words, the number of events in this event A is n1. And let's say B has the elements B1, B2, all the way up to B sub n2. So that means the number of elements in the sample, in the events rather, B is n2. Then we define the Cartesian product as the event A cross B. So that's the way we say it and write it. So almost like it's saying A times B, but we say A cross B. And this is defined as the set of all ordered pairs AI, BK, where I runs through the number of elements in A and K runs through the number of elements in B. Okay, so that ordered pair AI, BK, the fancy mathematical word for it is called a two-tuple. But essentially that just means an ordered pair. Okay, where the first element inside that pair comes from the first set A, and the second element comes from the second set B. So let's have a look at an example. Let A be HT, so the event of landing on heads or tails after flipping a coin. And then let B be the event 1, 2, 3, 4, 5, 6. That is the event of rolling a single die and noting the number that it lands on. Okay, so there are two events that are happening here simultaneously. We are tossing a coin and noting whether it's heads or tails. And then we are rolling a die, so a single, not a pair of dice, but a single die. We're rolling that on a table and we're seeing what number comes up from 1 to 6. So what does the space look like when we first toss the coin and then roll the die? Well, that is defined by the Cartesian product of those two sets. So here are all the outcomes. You could have a heads first and then roll a 1. You could have a heads first and then roll a 2, and so on, all the way up to tossing a heads first and then rolling a 6. Then we could have either a tails and then tossing a 1, tails tossing a 2, all the way up to tails tossing a 6. So let's note something quite special that happens here. The number of elements in the set A, there are 2 elements here. And the number of elements in the set B, there are 6 elements here. And the number of elements in the Cartesian product A cross B, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But 12 is 2 times 6. So this brings us to what we call the fundamental counting principle. If there are n1 objects in the event A and n2 objects in the event B, then the total number of objects that we can have from both A and B, so essentially the number of elements in the Cartesian product, is n1 times n2. So the number of elements in A times the number of elements in B. That is for 2 sets, but the fundamental counting principle can be further generalized to any number of events. So if you have A1, A2, all the way up to AK events, and they each have n1, n2, up to n sub k elements in each event, then we say that the total number of objects from all possible events occurring is n1 times n2 times n3 all the way up to nk. All right, so you're just multiplying the number of elements in each set together to get the total number of objects that we can have from all possible combinations of all these events happening at once. Okay, so let's have a look at an example of the fundamental counting principle. So Kyle visits a restaurant and has 3 meal courses that he must choose from. Each of the 3 meal courses have their own options. So in the first meal course, he can choose from a chicken, beef, or mutton bunny chow. In the second meal course, he must choose either a Coca-Cola, a Sprite, a Fanta, or a Pepsi. And in the third meal course, he can either have cake, brownie, or a scone for dessert, essentially. So how many different meal courses can Kyle have? Well, if you let A be the event of the first meal course, there are 3 options here: chicken, beef, or mutton bunny chow. B, there are 4 options of cool drink here to choose from. And in C, for the dessert, there are 3 options to choose from. So there we have those listed. So by the fundamental counting principle, Kyle has a total number of 3 times 4 times 3, which is 36 different meal courses that he could have, that he could choose from in that single night. Okay, and then choosing one of the 36 possible combinations is counted as an event from the set A cross B cross C. So for example, so the number of elements in that is 36. So what does an element look like from this space? Well, he could have something like this. It could be beef, Pepsi, and then cake. So that could be a possible element in the set A, B, C. A cross B cross C. Another possible element could be mutton, then Sprite, and then scone, for example. That's another possible element of A cross B cross C. So all these different combinations that he can choose from, there are 36 different combinations that he can choose from between those given meal course options. And that is using the fundamental counting principle. All right, I'll see you in the next one.